Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 8.0b on our series on adding and subtracting fractions. We're going to be taking a look at how to find the lowest common denominator and how to write the given fractions as equivalent fractions using the LCD. The type of problems that we're going to be covering in this tutorial are depicted here. We're to find the LCD of the given fractions 1 over 4 and 1 over 5. If you do not know how to find the lowest common multiple, which is a prerequisite skill for this lesson, go ahead and scan this QR code right here and do a real quick review on how to find the LCM, and then you can come back to this presentation. Don't forget, we have some practice problems at the end of this video for you to try out to demonstrate mastery of what we're talking about in this lesson. Alright, so the instructions for the examples we're going to be going over are as follows. We're to find the LCD of the given fractions and then express them as equivalent fractions with a common denominator. Alright, so for question number 1, let's say we have the fractions 1 over 4 and 1 over 5. Alright, so there are going to be two parts to the questions that we're going to be doing. Okay, we're going to find the LCD first and then write the two fractions as equivalent fractions with identical or a common denominator. Okay, so let's go ahead and get started with the solutions. So part 1, we're going to call it part A of the problem, is as follows. We're to find the LCD of the given fraction 1 over 4 and 1 over 5. Okay? Now, in order to find the LCD of 1 over 4 and 1 over 5, we have to start off by finding out the LCM of the denominators. Okay? So we're going to transition to, first of all, we're going to find the lowest common multiple of the denominators, namely 4 and 5. 4 and 5. Alright, that will be our focus. So as indicated earlier, we went over how to find the LCM, lowest common multiple of two numbers, in the previous presentation, section 8.0a. So you can definitely review that if you're not proficient in this skill. Okay. Alright, so let's go ahead and go over that again. So we want to find the LCM of 4 and 5. So what that basically means is, in the multiplication facts of 4 and 5, what is the smallest number that shows up in both multiplication facts or tables? Okay, or what is the smallest number that these two numbers can go into evenly without a remainder? So we're going to start off by writing down the multiples of 4 all the way to 5, and then write down the multiples of 5 all the way to 4. And then we see if we can find a common multiple. If not, we just go and add one common multiple for each column until we can hit a common number in both columns. Alright, so let's start with 4. What are the multiples of 4? We're going to go over our multiplication facts. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. Okay, now let's go to the 5 column. This is our 5 multiplication facts. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. Okay? Alright, do you see any number that's common in both? The 4 is multiplication fact and the 5 multiplication facts. Absolutely, we can see that 20 is common. Okay? That's the smallest common number. There are other numbers that are going to be multiples of both of these two, but this is the first one. This is the smallest one. That's what we're looking for, and that is basically the LCM of the denominators. Alright, so let's go ahead and write down the significance of what we just found. So the LCM of 4 and 5 is 20. So what does that mean in the context of this problem? If you have two fractions and you find the LCM of the denominator numbers, guess what? That number is equal to the LCD of the fractions. So the lowest common divisor of the fractions that contain these digits as their denominators, namely 1 over 4 and 1 over 5, guess what? Is 20. Okay, so this is the answer to the first part, the LCD of 1/4 and 1/5. Okay, all right, so now what we're going to do next is we're going to write these two fractions as equivalent fractions, basically the same size as 1 over 4 and 1 over 5, but having the denominators as the LCD. Okay, so let's specify what we're about to do. Part B, we're to write the two fractions 1 over 4 and 1 over 5 as equivalent fractions. Basically, you're not altering their value or their size. Okay, as equivalent fractions with a common denominator. Remember, every fraction has an infinite number of representation. Okay, but we're looking for that special one where the denominators are going to be common, the least common denominator, namely. Okay, all right, so let's go ahead and do it. So we have 1 over 4 and 1 over 5. What is our target number? Our target number is 20. Where did that 20 come from? Well, the 20 is the LCD that we just found in part A, okay? So in order to do this, we're going to be multiplying these numbers by 1. When you multiply a number by 1, it doesn't change the number. It's a multiplicative identity, right? So as indicated earlier, every number or fraction has infinite representations. The same rule applies to 1. So one of the representations of 1 is one that could change the denominator of this 1 over 4 into the target LCD, which is 20. So the question is, 4 times what gives you the LCD? Is 4 times 5. Okay, so we're going to multiply the top and the bottom by 5. 5 over 5. Why 5 over 5? Because 5 over 5 is the same thing as 1, right? So we're not changing the fraction. It's going to be equivalent. We're just changing how it looks. But when you reduce it, you end up with 1/4. All right? So multiply top by top, which is 5 over 20. So we have an equivalent fraction of 1/4 that has a denominator equal to the LCD. The same with 1 over 5. What do you multiply 5 with to hit 20? Multiply the numerator by exactly the same number. Okay? So the number we desire is 4. Multiply top and bottom by 4. And then we get 4 over 20. Now take a look at these two fractions we just created. What do you notice? They both have a common denominator, which is equal to the least common denominator. All right, so let's go ahead and write this down. 1 over 4 and 1 over 5 written with the LCD is what? They are going to be 5 over 20 and 4 over 20. All right, so you might be wondering why is this important? Well, if you want to carry out operations such as adding and subtracting fractions with different denominators, it's imperative to find the LCD first so that you can carry out your computation. Okay? All right, so there goes the answer to the B part. We're writing the fractions with a common denominator, the least common denominator to be specific. All right, let's take a look at another example. Okay, so for number 2, let's say we have the fractions 3 over 2, improper fraction, and 4 over 7. So first task is to do what? We are to find the LCD of the fractions. Okay, so part A, find the LCD of 3 over 2 and 4 over 7. Now how do you accomplish that? You start off by finding the least common multiple of their denominators. Alright, so find the least common multiple, LCM, of their denominators. What are their denominators? 2 for the first fraction and 7 for the second fraction. Okay. Alright, let's do it. So we're going to use the same approach that we used in the previous example and previous presentation on finding LCM to do this. So let's start with it. Always start with a smaller one, okay? So 2, let's write down the multiples of 2 all the way to 7, okay? So 2, 1, 2, 2, 2, 4, 2, 3, 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. Bam. Alright, so there goes your multiplication facts for 2 all the way to 7. And then we just do the multiplication facts of 7 all the way to 2 and see if we can find the LCD. If not, we just keep adding more numbers. 7, 1, 7, 7, 2, 14. Oh, there you go. We have our least common multiple, which is 14 because it shows up, is the smallest number that shows up in both of the two columns. Alright, so that's our LCM right there. What does this mean? It means that the LCM of the denominators of the two fractions, 2 and 7, is 14. How does that relate to our answer? Well, it tells us that the LCD of the fractions that have these numbers as their denominator, namely 3 over 2 and 4 over 7, the LCD is 14. Bam. There goes the answer to the first part. Okay. Now the second part, we're to write both fractions as equivalent fractions with their denominators equal to the LCD. So let's go ahead and do that. So part B, we want to write 3 over 2 and 4 over 7 as equivalent fractions with their LCD. Okay. Alright, so let's do it. So the first fraction is 3 over 2. And then the second fraction is 4 over 7. So we're going to be multiplying both of them by a version of 1 that will cause their denominators to be equal to the LCD. Okay. So 4 over 7. LCD is 14. So what do we multiply 2 by to get 14? 7, right? 2 times 7 is 14. So we multiply the top by the same number because 7 over 7 is 1. We want it to be equivalent, right? So we must multiply it by 1. 3 times 7 is 21. 2 times 7 is 14. 21 over 14 and 3 over 2 are exactly the same number. They are equivalent fractions. But the denominator of this resulting fraction we have here is the LCD. Beautiful. Now multiply the same, follow the same pattern, and then determine what to multiply 4 over 7 by. Okay? 7 times what gives you the LCD? 14. 7 times what gives you 14? 7 times 2. Notice you start from the denominator first. What makes the denominator equal to the LCD? And you apply exactly the same number to the numerator so that you have an equivalent fraction. Alright? 4 times 2 is 8. 7 times 2 is 14. Significance of our answer, 3 over 2 and 4 over 7 written with the LCD, with their LCD. are going to be 21 over 14 and 8 over 14. Okay, remember these two fractions, even though they look different from 3 over 2, they are exactly the same value upon simplification. All right, one more problem and then we'll give you some practice problems to try out. All right, so for question 3, what if you have the fractions 5 over 6 and 3 over 8? All right, so first task is to find the LCD of the two fractions. So part A, find the LCD of 5 over 6 and 3 over 8. How do you do that? To find the LCD of two fractions, you have to find the LCM of their denominators. Alright, so what we're going to do is find the least common multiple of the denominators, which are 6 and 8. Okay, so let's make a chart to aid us with this computation. So what we're going to do is write down the multiples of 6 all the way to 8. And then the multiples of 8 to 6. Or we can just pay attention to the multiples of 8 that we're generating. When we find a common number, we can just stop there. Alright, so starting from 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6, 5, 30. 6, 6, 36. 6 6 times 7 is 42. Oh, I skipped the number. No, that's fine. Okay, 6 times 7 is 42. And 6 times 8 is 48. Alright, now 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. We can keep going, but if you notice, we already found a number that shows up on both columns, namely 24. So that right there is your LCM. You don't have to keep going blindlessly. When you're filling out a second column, you want to pay attention to the first column to see if any multiple you generate is already present in the first column. As soon as you get a match, you stop right there, and that's your LCM. Okay? Alright, so what does this mean? The LCM, the least common multiple of the denominator values 6 and 8, is 24. What does that help us find? Well, it tells us that the LCD of the fractions with these numbers as their denominators, namely 5, 6, and 3/8, the LCD of these two fractions is 24 also. Bam, there goes the answer to the first part of the question. Okay. Alright, let's do the B part. Alright, so for the B part, what are we going to do? So for the B part, we're to write the two fractions, 5 over 6 and 3 over 8, as equivalent fractions. With their common denominator, with their LCD. Okay? Alright, so 5 over 6 and 3 over 8, we're going to rewrite them using as equivalent fractions, but the denominators both have to be equal to 24. Okay? Alright, so 5 over 6, what are we multiplying 6 by to get 24? 6 times 4 is 24, so multiply the numerator also by that value. So you're going to get 20 over 24. Excellent. That's what we want. Okay, remember 20 over 24 and 5 over 6 are equivalent. They're the same value. But this has a denominator that's equal to the LCD of 5, 6, and 3/8. Okay? How about 3/8? What do we multiply? Remember, you always start with the bottom. Okay, what do we multiply the denominator by to change it into the LCD? 8 times what is 24? 8 times what gives you this LCD right here? 8 times 3 is 24. So you put the same value on top because you're in essence multiplying by one of the forms of 1. Whenever you multiply by 1, you end up with an equivalent fraction. Okay, 3 times 3 is 9. 8 times 3 is 24. There goes your two equivalent fractions as the original, but they have the same denominators, which is the LCD. Okay, so let's write down what our final answer means. 5 over 6 and 3 over 8 written with your LCD are what? 20 over 24 and 9 over 24. Ladies and gentlemen, that goes the answer to the second part of question number 3. Okay, so now it's your turn to do some practice problems. All right, so we have 3 practice problems for you to try out. So what I would like you to do at this time is pause the video presentation and try out these 3 problems. When you're done, click on the playback button and we're going to reveal what the answers are. All right, so go ahead and pause and try out these examples. Alrighty, welcome back. Hopefully you had a chance to try out the 3 practice problems. So go ahead and check your answers at this time. So how well did you do? Let us know how well you did in the comment section below. If you got them all right or did well, go ahead and destroy that like button. If you have any questions, specify it in the comment section below and we'll be more than glad to support you. Thanks again for taking the time to watch this presentation. Don't forget to help support our channel by liking this video, subscribing and sharing with your friends. Tons of support resources can be found at Mathgotserved.com. And to gain access to our entire arithmetic course, just scan the QR code or take a look at the links in the description below. Thanks again for watching and we'll see you in the next video. Goodbye.